Have you ever dreamed of traveling through space, discovering worlds so strange and wonderful that they seem to defy the imagination? Imagine a universe where planets have no solid surface on which to land, gas giants, composed almost entirely of gas, where storms rage for centuries and winds blow at speeds beyond human comprehension. These worlds, gigantic and mysterious, are the gaseous planets of our solar system: Jupiter, Saturn, Uranus, and Neptune. Each of them is a universe in its own right, with its own secrets, beauty, and stunning natural phenomena. What mysteries do they hide in their unfathomable depths? How can planets composed entirely of gas exist? And what unimaginable wonders lurk in their tumultuous atmospheres? Dear traveler, welcome. Today we're off on an epic journey through space, discovering gas giants. But before you set off on your next adventure, don't forget to like the video and subscribe so you don't miss a thing. Thank you, and have a great trip. Our solar system is made up of 8 planets orbiting the Sun. Pluto, long considered the 9th planet, has not been classified as such since 2006. The 8 planets are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The first 4 are called telluric planets. They are made up mainly of rocks and metals. You're on one of them, Earth. Jupiter, Saturn, Uranus, and Neptune are gas planets, or gas giants, or Jovian planets. The term Jovian comes from Jupiter, the largest of these planets. These planets are mostly made up of gas, but we'll see later that this definition is a little simplistic. Why aren't the 4 planets furthest from the Sun solid? Precisely because they're far from the Sun. Solar luminosity has defined 2 distinct zones in the solar system, separated by what is known as the ice line. This imaginary demarcation plays a crucial role in the composition and formation of the planets. To understand why the 4 planets furthest from the Sun, Jupiter, Saturn, Uranus, and Neptune, are not solid, it's essential to delve into the mechanisms of planetary formation and the influence of distance from the Sun. The ice line, also known as the frost line, marks the boundary in the protoplanetary disk. This is a disk of gas and dust that surrounds a young star during the formation of a star system. Beyond this boundary, the temperature is low enough for volatile compounds such as water, methane, ammonia, and carbon dioxide to condense into ice. This line is generally located at a distance where the temperature falls below about -123 degrees Celsius or -190 degrees Fahrenheit, allowing these compounds to change from a gaseous to a solid state. The exact position of the ice line can vary according to the luminosity of the central star and other local factors within the protoplanetary disk. In our solar system, it is located at around 5 AU, or 5 times the distance from the Earth to the Sun. Inside the ice line, warmer conditions prevent the formation of ice, limiting the materials available to refractory compounds such as silicates and metals. These materials form grains that gradually aggregate to create planetesimals and eventually telluric planets with solid cores. The Earth, Mars, Venus, and Mercury formed in this zone, characterized by rocky surfaces and predominantly solid compositions. Beyond the ice line, on the other hand, the significant drop in temperature allows volatile compounds to condense. This accumulation of ice increases the amount of material available for planetary formation, facilitating the rapid growth of planetary cores. These cores can then attract and retain huge quantities of gas from the protoplanetary disk, forming the massive envelopes of the gas giants. Jupiter and Saturn, with their hydrogen and helium-dominated compositions, formed relatively close to the ice line, effectively capturing these light gases. Further out, Uranus and Neptune, often referred to as ice giants, have compositions that include a greater proportion of frozen, volatile compounds. They were born almost at the same time as the Sun, 4.55 billion years ago, within the same cloud. It all began with a cloud of gas and dust that collapsed under its own weight, forming a disk. The bulk of the matter concentrated in the middle, where the Sun was born. The remaining dust and gas continue to rotate in a particular pattern. The heavier elements remain close to the Sun, in the center of the disk, while the lighter elements move towards the periphery. These light elements are, as you may have guessed, gas and dust. Two dust particles have met to form a slightly larger one. This is repeated by snowball accretion until baby planets are formed, called protoplanets, which can have 10 times the mass of the Earth. The mass of these protoplanets, made of rock and sometimes ice, begins to attract nearby debris. This debris includes the surrounding gases. The accumulation of these gases increases the mass. The critical mass of the solid core is reached after 8 million years and constitutes around 15 Earth masses. Gas accretion then becomes exponential, and the protoplanet becomes a gas giant. It's this very mass that still enables gas giants to hold these gases around them. The solid core provides the gravitational force needed to hold the gas envelope in place. Without it, the solar winds would have swept the gases away long ago. This so-called solid core explanation is the one that currently prevails for the formation of gas giants. But the debate on the formation of gas planets is still far from settled. A second scenario is that of gravitational instability. Giant planets are formed in the same way as stars. The protoplanetary disk can become gravitationally unstable, collapsing and fragmenting into bodies whose typical mass is of the order of Jupiter. Such a mechanism could produce a Jupiter-mass body in 1,000 years. The latter scenario is unlikely, but not out of the question. Giant planets don't just have gas in common. They all have a ring, even if Saturn's is the most prominent and famous. They also all have satellites. The presence of such planets in a star system has far-reaching consequences. It stabilizes the orbits of all the planets, and they form an effective screen against stellar objects. In this way, the presence of life on Earth has been greatly favored by our four giants, especially the nearest and largest, Jupiter, Jupiter and Saturn are composed mainly of hydrogen and helium, the two most abundant elements in the universe. This composition is remarkably similar to that of the Sun and other stars, which are also composed largely of these same elements. Hydrogen and helium were the first elements formed after the Big Bang, and they make up the majority of baryonic matter in the universe. Nuclear fusion is the process by which stars, including the Sun, produce their energy. It occurs when temperatures and pressures in the core of a star are high enough to allow hydrogen to fuse into helium. Although Jupiter and Saturn are composed of the same elements, they do not meet the necessary criteria in terms of internal mass and pressure to initiate and sustain nuclear fusion reactions. For nuclear fusion to occur, a star must have a mass of at least 8% of that of the Sun, which is well beyond the mass of Jupiter, the most massive of the planets, which represents around 0.1% of solar mass. Despite their inability to trigger nuclear fusion, Jupiter and Saturn are planetary behemoths. Jupiter is the largest planet in the solar system, with a diameter more than 11 times that of the Earth, while Saturn is not far behind. Their large size and gaseous composition mean that they have relatively low densities. In fact, Saturn has an average density lower than that of water. Unlike telluric planets like Earth, which have solid surfaces, Jupiter and Saturn have no clearly defined solid surface. Their surface is made up of dense layers of gas that become progressively hotter and denser as they descend towards the core. A dive into these planets would be a descent through increasingly dense layers of gas, with temperatures and pressures rising to levels far beyond those found on Earth. As we penetrate deeper into gas giants, we encounter more extreme conditions. Although these planets have no solid surface, their inner layers exert colossal pressures and temperatures. These conditions can lead to the formation of seas of metallic hydrogen, a state of hydrogen under such intense pressure that it adopts electrical and thermal properties similar to those of metals. This hydrogen phase contributes to the strong magnetic field of these planets, particularly Jupiter. These planets have received very few visits. Only 8 probes have left the inner solar system. They have taught us a great deal about these gas giants, but there is still much to discover. Every little discovery raises new questions. Saturn's rings, which look uniform from Earth, are actually a sea of ice chunks dancing around the planet. The Voyager 1 and 2 probes made it possible to observe this phenomenon. Voyager 2 was the first and only probe to fly over Uranus and Neptune. Launched in 1977, they benefited from the gravitational assistance of Jupiter and Saturn. Tested in the 1970s, the mastery of gravitational assistance took off with the Pioneer 10 and 11 probes, followed by Voyager 1 and 2. These 4 probes enabled us to discover the furrows in Saturn's rings, Jupiter's turbulent atmosphere, and the first resolved images of Uranus and Neptune. Gravitational assist is the process of using the attraction of a celestial body to modify the direction and speed of a spacecraft's trajectory. Specialists calculate the probe's trajectory so that it passes as close to the planet as possible without crashing into it. It's as if the planet served as springboards for the probes. Without it, the probes would have to carry a colossal amount of fuel, making any mission impossible. The most spectacular example is Voyager 2. Taking advantage of an optimal alignment of the 4 outer planets, the probe launched at just the right speed during a launch window, took advantage of the Earth's rotation speed around the Sun to reach Jupiter in 2 years. And that's not all. As it reaches the right speed to accelerate and change direction, so as to find itself on Saturn's trajectory 18 months later, 4.5 years later, it reached the trajectory of Uranus. This gives it the impetus it needs to find itself in the path of Neptune 3.5 years later. What a long and fascinating journey. As luck would have it, the alignment of the planets required for such a ballet only occurs every 176 years. Voyager 1 and 2 continue their journey to infinity today. Only Jupiter and Saturn have been the subject of dedicated missions, with 3 probes in orbit: Galileo, Juno, and Cassini-Huygens. These 3 probes have provided us with a wealth of information on the gaseous planets. Galileo disintegrated in Jupiter's atmosphere on September 21, 2003. This programmed end by NASA prevents it from polluting the moon Europa that we want to study. Cassini plunged into Saturn's atmosphere and disintegrated there in September 2017 for lack of fuel. Huygens stopped transmitting data after landing on Titan. Only Juno orbits Jupiter today. The probe arrived in 2017, revealing Jupiter's detailed appearance. Let's explore this first gas planet. Jupiter is the largest of the gaseous planets and the closest to the Sun. It lies around 778 million kilometers, or 480 million miles from the Sun. The Earth, by comparison, is 150 million kilometers, or 93 million miles from the Sun. Its period of revolution around the Sun is almost 12 years. It is the largest of the planets, but it is also twice as heavy as all the other planets in the solar system combined. It alone accounts for over 70% of the mass orbiting the Sun. In Roman mythology, Jupiter is the master of the gods ruling the sky, light, lightning, and thunder. Jupiter is enormous with a diameter of 143,000 kilometers, or 89,000 miles. It could hold 1,300 times the size of the Earth. Galileo was the first to observe it in detail in 1610. When viewed from space, all we see are white cloud bands against a background of orange, red, or beige atmosphere, parallel to the planet's equator. These are gaseous masses dragged along by the planet's rotation. Jupiter's cloud bands, visible as stripes parallel to the equator, are the result of the planet's atmospheric circulation. These bands are classified into zones: light bands, and belts, dark bands. with zones representing regions of rising hotter gases and belts indicating descending colder gases. This alternation is a direct consequence of Jupiter's rapid rotation, which completes one revolution on itself in around 10 hours, creating enormous Coriolis forces that shape atmospheric circulation. The chemical composition of Jupiter's atmosphere plays a crucial role in its coloring. Although it is mainly composed of hydrogen, around 90%, and helium, around 10%, it is traces of compounds such as methane, ammonia, as well as various sulfur and phosphorus-containing compounds that contribute to its varied colors. Methane, for example, absorbs light in the red and infrared, contributing to blue and green hues. Color variations between bands can also be attributed to differences in chemical composition, cloud particle size, and cloud altitude. Jupiter's atmosphere, with an impressive thickness of 5,000 kilometers or 3,100 miles, is extremely deep compared with that of the Earth. This depth allows the existence of several layers of clouds, composed mainly of ammonia, ammonium sulfide, and water, located at different altitudes. Pressure and temperature increase with depth, leading to the formation of metallic hydrogen in the deepest layers of the atmosphere, a key component of Jupiter's powerful magnetic field. Jupiter's atmosphere is the scene of extreme weather phenomena, the most famous of which is the Great Red Spot, a gigantic anticyclone 3 times the size of the Earth, observed for over 300 years. Storms on Jupiter can reach speeds of several hundred kilometers per hour, testifying to the dynamic energy and complex processes at work in its atmosphere. The Great Red Spot has been spinning for at least 100,000 years. Today, it is 15,000 meters or 50,000 feet long and 13,000 kilometers or 8,000 miles wide. On Jupiter, the equatorial bands circulate horizontally, while the matter circulates vertically. This generates winds of up to 600 kilometers per hour, or 370 miles per hour, and creates gigantic vortices. If by magic an observer were to penetrate this planet's atmosphere, paleontologists believe he or she would sink without encountering any limits through a thick layer of gas, mainly hydrogen. Then, without transition, it would pass through fluid layers as if the air were gradually being transformed into water. In reality, it's liquid hydrogen and helium. Our visitor would eventually reach, at a depth of 57,000 kilometers or 35,000 miles, a hard layer, the planet's core, a tiny seed at the heart of this giant. This core would be almost twice the diameter of the Earth's, at least 10 times more massive, and above all, extremely hot. It would reach 30,000 degrees Celsius or 54,000 degrees Fahrenheit. Like all gaseous planets, Jupiter has a ring system. Revealed by the Pioneer 10 probe in 1974, they are so tenuous that they are only visible against the light. Due to the planet's gravitational influence, the particles have coalesced into a very thin disk. This ring system, photographed by Voyager, seems to be fed by dust from Jupiter's closest satellites. But where do they come from? These rings are very thin, very fine-grained, and very close to the planet. The most likely scenario for their origin suggests that they are made of material that was not used to form the planet's hard core. As these blocks of rock are too close to the planet, they are under its influence and have not been able to agglomerate to form a satellite. These rings appear to be totally stable. They are unlikely to evolve over the coming millennia. Jupiter has a host of satellites, at least 95, of which 57 have been given official names. The astronomer Galileo discovered 4 of them, visible through a telescope, which is why they are called Galilean. This discovery proved that not all bodies revolved around the Earth, and helped place the Sun in its rightful place, at the center of the universe. He observed them at length when he discovered Jupiter, using an astronomical telescope he had built. Let me introduce them to you. The closest Galileo moon to Jupiter is Io. Its diameter is 3,642 kilometers, or 2,300 miles. Its distance from Jupiter is 422,000 kilometers, or 260,000 miles. Its period of revolution around Jupiter is 1.8 days. From a distance, it looks like a white, yellow, and orange marble. Some astronomers call it a pizza. Its volcanism is very active. Images taken by the Voyager and Galileo probes show numerous sulfurous eruptions. Up to 300 volcanic vents have been recorded. An image of Io shows the Pele geyser spewing jets of sulfuric acid. The surrounding plains are marked by yellow, red, orange, or black sulfur flows, depending on the temperature at which the sulfur has solidified. This would be due to the strong influence of Jupiter and Europa. The 2 neighboring bodies are said to cause intense tidal forces, upsetting the satellite's equilibrium. Its surface is very young, as evidenced by the absence of meteorite craters. Deep down, its matter is molten. The day will come when Io will cross Jupiter's Roche limit. This is the zone where the planet's gravitational pull breaks everything apart. Io will then be destroyed, and its debris will form rings similar to those of Saturn. Next comes Europa. Its diameter is 3,130 kilometers, or 2,000 miles. Its distance from the planet is 671,000 kilometers, or 415,000 miles. Its period of revolution around Jupiter is 3.5 days. Europa is the smoothest body in the solar system. This Jovian satellite has a surface as smooth as a billiard ball. When meteorites smash into its frozen surface, they release a lava of water that solidifies, erasing all traces of the impact. It's all covered in ice, under which an ocean could exist. Next comes Ganymede. With a diameter of 5,260 kilometers, or 3,300 miles, it is the largest satellite in the solar system. Its distance from the planet is 1 million kilometers, or 620,000 miles. Its period of revolution is 7.2 days. Analysis of its soil reveals highly complex geological activity, with terrains of different ages. Finally, Callisto. Its diameter is 4,800 kilometers, 3,000 miles. Its distance from the planet is 1.8 million kilometers, or 1.1 million miles. Its period of revolution is 16.7 days. This icy body features numerous impact craters, including a gigantic circular structure 600 kilometers, or 370 miles long, called Valhalla. It was formed by an asteroid collision. Its subsoil is said to contain an ocean of salt water. Technological advances have enabled us to identify ever smaller objects and to count at least 95 Jovian companions. But the situation evolves regularly. With each new technological step in the precision and range of tools, new, even smaller objects are spotted. The Galileo probe plunged as far as 160 kilometers, or 100 miles, into the interior of Jupiter, i.e., less than 0.2% of its radius, before being destroyed by the extreme conditions of temperature and pressure. Scientists are still assiduously studying Jupiter, as there is still much to discover. In May 2020, thanks to the Gemini telescope, located in Hawaii, they succeeded in capturing the smallest details ever seen from the ground in its atmosphere in infrared light. In August 2022, the James Webb Space Telescope delivered another unprecedented infrared image. It reveals mists and auroras on Jupiter's surface. NASA's Juno spacecraft is currently orbiting the planet. Thanks to Juno, we know that water accounts for 0.25% of the molecules in Jupiter's warm atmosphere at its equator. On April 14, 2023, ESA launched an ambitious mission. Jupiter Icy Moon Explorer, or JUICE, is due to reach its destination in 2031. It will explore 3 of Jupiter's satellites, Callisto, Europa, and Ganymede. They are suspected of harboring an ocean beneath an icy crust. Let's continue our journey with the second closest gaseous planet to the Sun, Saturn. We know it best for its complex ring system, the most extensive in the solar system. When Galileo first saw them, he was unable to identify them. In his early sketches, Saturn appears to have 2 large ears. Before Galileo, the first to observe the planet was the Gallo-Roman astronomer Ptolemy in the 2nd century. He identified it as a wandering star due to its slow evolution around the Sun. It is named after Saturn, the Roman god of time. This god guided men and taught them how to use the tools needed to work the Earth. It lies 1.4 billion kilometers, or 900 million miles from the Sun. Its diameter is 120,000 kilometers, or 75,000 miles. This beautiful planet has cloud layers similar to those of Jupiter. Its pale yellow hue comes from ice crystals composed of a chemical called ammonia in the upper atmosphere. One of its distinctive features is the Great White Spot. This is a storm in Saturn's northern hemisphere that occurs periodically, about every 30 years. It can extend over thousands of kilometers or miles and lasts for several months. Saturn has Aurora Borealis in the north and Aurora Australis in the south, caused by the interaction between charged particles in the solar wind and Saturn's magnetic field. Like its neighbor Jupiter, Saturn has a small core. This core is probably made up of a mixture of molten rock and metal. It has a temperature of 11,700 degrees Celsius, or 21,000 degrees Fahrenheit, and a diameter of around 25,000 kilometers, or 16,000 miles, twice that of our Earth. A layer of metallic hydrogen and helium, 10,000 to 12,000 kilometers, or 6,200 to 7,500 miles thick, surrounds this core. The layer is itself surrounded by another 5,000 kilometers, or 3,100 miles thick, made up of metallic hydrogen and helium, whose drops rain down towards the center of the planet. All this is surrounded by a third layer, 3,000 kilometers, or 1,900 miles thick, made up of 93% molecular hydrogen and 7% helium. To this must be added a little carbon, oxygen, metals, and nitrogen, the proportions of which have yet to be defined. These very high temperatures and pressures make hydrogen an electrical conductor, generating a powerful magnetic field 500 times greater than that of the Earth. Saturn is characterized by low density. Immersed in a bathtub its size, it would float. It also has an internal energy source 1.76 times more intense than the solar radiation absorbed by the planet. Its rotation, almost identical to that of Jupiter, stretches cloud formations into colored bands parallel to its equator. Its rotation period is 10 hours, 39 minutes, and 24 seconds. Its period of revolution exceeds 29 Earth years. Its axis of rotation is inclined at 26.7 degrees, giving rise to seasonal variations as on Earth. A Saturnian season lasts 7.5 Earth years. Saturn has an eccentric, elongated trajectory, which means that when it is closest to the Sun, its atmosphere is the site of storms, with winds of up to 2,000 kilometers per hour. These storms occur approximately every 30 years. So Saturn didn't have big ears. It was in 1659 that astronomer Huygens described these structures as a rigid, hard layer of matter. In 1785, the astronomer Laplace asserted that this structure, like a hoop, must be rotating to be able to maintain itself around the planet. In 1857, it was discovered that this ring was made up of a multitude of small objects, boulders or meteorites, moving in independent orbits. These objects vary in diameter from a few centimeters to a few meters, and some are the size of buildings. In 1848, Edward Roche discovered that there was a distance between a body and a planet below which the body could only be deformed and explode. That's why the blocks that make up the rings can't agglomerate into larger bodies. They're too close to Saturn. This distance is called the Roche limit after its inventor. Since the 1970s, our knowledge has evolved thanks to repeated visits by probes such as Pioneer, Voyager, Galileo, and Cassini. Cassini orbited the planet for 13 years, from 2004 to 2017. It will take several decades to exploit the data collected. The structure of these rings is extremely complex. 3 large bracelets are easily distinguishable, themselves made up of dozens of tangled rings. No boundaries are really visible between these bracelets, which are nonetheless distinguished by differences in particle density. Another astonishing feature of these rings is their thinness. Their thickness is less than a kilometer, whereas they extend to more than 300,000 kilometers, or 185,000 miles from Saturn's center. Reduced to the size of a soccer pitch, they would be thinner than cigarette paper, yet their combined mass is equal to that of a small planet. Between these rings are what are known as shepherd satellites. Like good shepherd's dogs, they bring back any blocks that try to escape. They don't show their fangs, but use their gravitational influence. The rings are named in alphabetical order, from A to G. The closest to the planet is the D ring, made up of ice particles and dust. The B ring, made of ice and water, is the brightest. The Phoebe ring takes its name from the eponymous satellite whose dust it collects. In addition to its rings, Saturn has numerous satellites, including Titan, an enormous moon with similarities to our Earth. Titan's diameter is 5,150 kilometers, or 3,200 miles, or 1.5 times that of the Moon. Its period of revolution around Saturn is almost 16 days. Titan alone accounts for 96% of the mass orbiting the planet. It is massive enough to retain an atmosphere. This atmosphere, composed of nitrogen and methane, gives Titan a beautiful orange color. On October 15, 1997, the Cassini orbiter was launched from an American rocket. On board was Huygens, a European probe measuring 2.7 meters in diameter and weighing 350 kilograms, or 770 pounds. Huygens, for whom the model is named, was a Dutch astronomer who discovered 4 of Saturn's satellites: Iapetus in 1671, Rhea in 1672, Tethys and Dione in 1684. The Cassini probe's mission is to visit Saturn and its satellite Titan. Cassini approached the planet after a 7-year, 3.5 billion kilometer journey. To get there, the probe used the gravitational assistance of Venus, Earth, and Jupiter. The latter provided the impetus needed to reach its destination. On July 1, 2004, Cassini entered orbit around Saturn. It then orbited for 4 years. In January 2005, the small Huygens module landed on Titan's surface after a 22-day voyage. It enabled us to discover the soil of this strange satellite, surrounded by a nitrogen atmosphere. The presence of methane is very important, as the cycle of this gas is similar to the water cycle on Earth. So there could be life on Titan. Now you know why we're so interested. In 2023, there are 146 satellites on Saturn, 145 of which are confirmed. The last one is awaiting confirmation. Most were discovered in the 1980s, and even after 2000. Every year, probes and telescopes enable us to count new satellites. In October 2019, we announced the discovery of 20 new satellites, observed between 2004 and 2007. This brings the total to 82. Most recently, between May 3rd and 16th, 2023, another 62 satellites were discovered. Initially named after characters, notably the Titans of Roman and then Greco-Roman mythology, their growing number has forced astronomers to draw on other mythologies. Their names define them according to their inclination. Satellites with an inclination of around 36 degrees were named after Gallic giants. We've talked a lot about Titan, but Saturn's satellites are as numerous as they are varied. Enceladus, for example, emits geysers of gas and dust, and may contain liquid water beneath its south pole. For the moment, this intense geological activity remains unexplained. Iapetus, on the other hand, is strangely bicolored. Half of its surface appears to be covered with a dark coal-like dust. For future space missions, it's not so much the planet Saturn that interests scientists, but rather its satellites. The Venus satellite, long neglected because it looks like an old rock, is currently the talk of the town. It has just been discovered that it harbors an ocean just 30 kilometers or 20 miles from its surface. This makes it all the more interesting for its potential to support life. We've also just discovered that the presence of water on Titan wasn't enough to create life. This is a disappointment for scientists, but nothing is lost. Titan is distinguished by its dense, nitrogen-rich atmosphere, as well as by its vast lakes and liquid seas on the surface, composed mainly of methane and ethane, unlike liquid water on Earth. This fundamental difference opens the door to the possibility of a totally different form of life from the one we know, one based not on water, but on methane. Methanogenic life on Titan would require a radically different biochemistry to that based on water on Earth. On our planet, water acts as a universal solvent in which the chemical reactions essential to life take place. On Titan, liquid methane could play a similar role, but with chemical reactions adapted to much lower temperatures, Titan having an average surface temperature of around minus 179 degrees Celsius, or minus 290 degrees Fahrenheit. Methanogenic life on Titan would probably involve metabolic mechanisms capable of taking advantage of the chemical energy available in its hydrocarbon-rich environment. This could include the use of compounds such as methane, ethane, or other hydrocarbons, as well as atmospheric nitrogen. The exact processes remain speculative, but could involve redox reactions where hydrocarbons act as electron donors or acceptors. Terrestrial organisms use lipids to build cell membranes, creating a barrier and a stable environment for biochemical reactions. On Titan, the extremely cold conditions and methane-based environment may require entirely different types of membranes, perhaps based on molecules that remain flexible and functional at cryogenic temperatures, such as certain types of silanes or membranes composed of nitrogen-rich molecules. Directly detecting methanogenic life on Titan is a major challenge. Missions like Dragonfly, a helicopter drone scheduled to leave Earth in 2028 by NASA to explore Titan 6 years later in 2034, aim to study its complex chemistry, hydrocarbon lakes, and potentially signs of biological or prebiotic processes. However, identifying concrete evidence of life will require a thorough understanding of abiotic chemical processes on Titan to clearly distinguish between complex organic chemistry and biological activity. The possibility of methanogenic life on Titan could have profound implications for our understanding of life in the universe. It would suggest that life could exist in environments considerably different from those on Earth, greatly expanding the range of potential habitats where life could be found. It would also challenge our conception of life and the conditions necessary for its development, highlighting the incredible adaptability of biological processes. This year, NASA is putting the finishing touches to another project, a robot that moves like a snake and is therefore able to negotiate all types of terrain. Called EELS, Exobiology Extant Life Surveyor, it could be sent to Enceladus. The trip would take 12 years. Until 1781, the solar system was thought to be limited to 6 planets. At that time, William Herschel, a music teacher with a passion for astronomy, began building ever larger telescopes. His record? A giant telescope with a diameter of 1.2 meters, or 4 feet, with which he discovered a new planet in March 1781. Can you guess? It's Uranus. Initially considered a comet, it acquired the title of planet in 1783. Its name comes from that of Saturn's father, called Uranus by the Greeks. Along with Neptune, Saturn is the only icy giant planet in our solar system. Mainly composed of hydrogen and methane, this giant planet has a rocky core with a temperature approaching 7,000 degrees Celsius, or 12,600 degrees Fahrenheit. Its diameter is 51,000 kilometers, or 32,000 miles. Its mass is 14.5 times that of the Earth, and it is 4 times larger. It lies about 2.8 billion kilometers, 1.7 billion miles from the Sun. A day on Neptune lasts 17 hours and 1 year 84 years. It holds the record for the coldest atmosphere, reaching minus 210 degrees Celsius or minus 346 degrees Fahrenheit. Its magnetic field is similar to that of the Earth. It has a curious peculiarity. It is literally lying on its trajectory. While other planets spin like tops, Uranus rolls like a ball in the plane of its orbit. As a result, each of Uranus's poles faces the Sun for 42 years at a time. It is thought that when Uranus was young, it was hit by a large celestial body, which caused it to tilt. Some call it the planet in bed. The temperature differences between its light and dark sides create a very strange meteorology. When we look at it, we see a large ball with a blue-green hue, rather faded. This pallor distinguishes it from the darker Neptune. This strange color is probably due to the presence of methane in its atmosphere. Methane absorbs red light in the solar spectrum and reflects blue light, giving Uranus its characteristic hue. But methane alone cannot be responsible for Uranus's characteristic color. If there were only methane, Uranus would be blue like Neptune. Scientists speculate that an unknown gas, a mysterious compound, may contribute to this particular shade of blue-green. At its center is a core of silicate rock, iron and nickel, slightly smaller than that of the Earth. This core is surrounded by a mantle of volatile components called ices, despite their state between liquid and solid. This mantle is around 10,000 kilometers, or 6,200 miles thick. The components are water, ammonia, and methane. All this is enveloped in an atmosphere composed of 83% hydrogen, 15% helium, and 2% methane. The icy giants have a mass well below that of Saturn or Jupiter, but represent 15 to 17 Earth masses. Only 20% of this mass is hydrogen, whereas on Saturn, hydrogen accounts for 90% of the mass. Much of Uranus's mass is stored in its ices. Uranus has only been visited once by Voyager 2 in 1986. The flyby lasted 5 hours and 30 minutes, just 80,000 kilometers or 50,000 miles from the planet. The probe was also able to observe the planet's rings. Uranus has 13 dark-colored rings. They represent the second ring system discovered after that of Saturn. Composed of minerals such as carbon, they are very thin and narrow, less than 30 kilometers or 20 miles thick. The Hubble Space Telescope revealed the two outermost rings in 2007, when the planet tilted in such a way that from the Earth its rings overlapped. The first rings were discovered in 1977. The rocks making up the rings contain little dust and consist mainly of boulders, 0.2 to 20 meters, or 0.6 to 65 feet in diameter. The rings are named Zeta, Alpha, Beta, Eta, Gamma, Delta, Lambda, Epsilon, Nu, Mu, and 654. Mu, the furthest ring from Uranus, has a lovely blue color. The same is true of Saturn's outermost ring. Both rings have moons, Uranus's Mab and Saturn's Enceladus. Astronomers believe that these satellites act as filters, capturing the ring's larger particles while allowing smaller ones to pass through. These particles, smaller than a micron, are thought to diffuse blue light. The Nu ring, close to Mu, has a beautiful red color. Uranus has 28 known natural satellites. They are named after characters in the works of William Shakespeare and Alexander Pope. The 5 major satellites of Uranus are Titania, Oberon, Miranda, Ariel, and Umbriel. William Herschel discovered the first 2 in 1787, 6 years after Uranus. William Lassell discovered Ariel and Umbriel in 1851, and Gerard Kuiper discovered Miranda in 1948. The other moons were discovered by Voyager 2 in 1985, and others by ground-based telescopes. The satellites have sufficient mass to be in hydrostatic equilibrium, i.e., stable in size and surface. 4 of them show signs of surface activity, such as the formation of canyons or volcanism. Uranus's largest satellite, Titania, is the 8th largest in the solar system, with a diameter of 1,578 kilometers, or 980 miles. According to a Japanese study published in 2020, the satellites of Uranus were formed by the impact of a body with the planet. This impact produced a disk of vapor, which condensed and produced ice particles. These particles would have formed the satellites by accretion. All of Uranus's major moons are composed of equal parts of rock and ice, except Miranda, which is essentially composed of ice. This ice may contain ammonia and carbon dioxide. In 2024, 10 irregular satellites are known to orbit Uranus. Their orbit is beyond that of Oberon. For the past 30 years, Uranus has not been one of NASA's priority missions, but things are about to change. In April 2022, the U.S. Space Agency unveiled its next missions for Uranus, Uranus Orbiter and Probe. Launch is scheduled for 2031. It will be 2044 before the expedition's probe orbits the planet, enabling new discoveries to be made. It will study the structure and origins of the planet, as well as the nature and formation process of its rings. Astronomers have high hopes for this expedition, as the planet is still the subject of many questions. Let's move on to the last gas planet, Neptune, the furthest from the Sun. Remember that the discovery of Uranus set tongues wagging. We weren't expecting it. By observing it closely, astronomers of the time realized that it wasn't turning as it should. Something was disrupting its trajectory, and that something might well be a planet. A race was on to find this invisible star first. While some of his colleagues scanned the sky, the Frenchman Urbain Le Verrier chose another method: calculation. By studying the perturbations in Uranus's motion, he tried to predict on paper where the new planet should be. In September 1846, he indicated its probable position to the German Johann Galle, who found the planet that very evening. For the first time, calculation was ahead of observation. After some debate, the new planet was named Neptune, a mythological name in harmony with the names of the other planets. Far more distant than Uranus, Neptune is nevertheless better known to us thanks to the Voyager 2 probe, which sent us some superb photographs in 1989. Neptune has a beautiful blue color. This is due to atmospheric layers rich in methane. With a diameter of 50,000 kilometers or 30,000 miles, Neptune is the smallest of our four gas giants. Its mass is 17.2 times that of the Earth, making it the third most massive planet in the solar system. This is 1/19th the mass of Jupiter. Neptune is the densest giant planet in the solar system. Its distance from the Sun is 4.5 billion kilometers, or 2.9 billion miles. A Neptunian year is 165 years long, and one day lasts 16 hours. Like Jupiter, it has a huge permanent cyclonic formation. It features a white secondary cyclone, which scientists have nicknamed the Scooter because of its speed. In the planet's southern hemisphere, Voyager 2 observed a large black spot, which appears to be similar in every way to Jupiter's red spot. Its origin is different, however, as a strong magnetic field is suspected. Neptunian meteorology is thought to be turbulent, as a comparison of images taken by the Hubble telescope in 1994 and those taken by Voyager 2 in 1989 reveals numerous differences. Some spots have disappeared, while new ones have appeared. The Great Black Spot no longer exists. Neptune's internal structure is similar to that of Uranus. It probably has a solid core of iron, nickel, and silicates. The pressure at the center would be twice as high as at the center of the Earth, and the temperature would be around 7,800 degrees Celsius, or 14,000 degrees Fahrenheit. Above this core, it could have a fairly uniform composition of different ices, hydrogen and helium. This sets it apart from Jupiter or Saturn, which have a layered structure. The internal structure of Uranus and Neptune is often modeled in three main layers. One, in the center, a rocky core of silicates and metals, similar in composition to the telluric planets, but much more massive. Two, surrounding the core is a thick layer of water, methane, and ammonia. However, the term ice does not refer to the solid state of these compounds as they would be on Earth, at 0 degrees Celsius or 32 degrees Fahrenheit. Under the extreme conditions of pressure and temperature found at this depth, these substances form a dense warm fluid, sometimes called hot ice or fluid ice. This phase is different from that of liquids or solids encountered in more familiar terrestrial conditions. 3. The outermost layer is a thick atmosphere composed mainly of hydrogen and helium, with a small amount of methane contributing to the characteristic blue-green color of these planets. This atmosphere extends over 8,000 kilometers, or 5,000 miles in thickness. It is this internal structure that is important in understanding why Uranus and Neptune are not simply smaller versions of Jupiter and Saturn. Differences in their composition and internal structure suggest different formation processes or varying initial conditions within the protoplanetary disk that gave birth to the solar system. Its internal heat is sufficient to generate planetary winds of up to 2,000 kilometers per hour, or 1,200 miles per hour, the fastest in the solar system. Neptune's temperature is far from stable. Variations of several degrees have been observed from one year to the next. Let's talk about another curiosity specific to Neptune and Uranus: diamond showers. For some years now, there has been a hypothesis circulating that diamonds are raining down from the heart of Neptune. But how is this possible? Scientists at Stanford University have reproduced Neptune's extreme conditions in the laboratory. They used polystyrene instead of methane and sprayed it with an optical laser. They observed a separation of hydrogen and carbon. The hydrogen escaped, and the carbon was transformed into diamonds. These diamonds would flow towards the center of the planet, rather than raining down on it. A dream come true, don't you think? Neptune is surrounded by a system of 5 rings, some of which display very bright concentrations of matter. These rings were discovered indirectly in 1984 from Chile. At first, they were thought to be incomplete, but Voyager 2's passage allowed us to see them in their entirety. By observing Neptune's passage in front of a star from Earth, we can make out their presence. They are dark, and their composition and origin are still poorly understood. One of them, called Adams, has 4 arches nicknamed Liberté, égalité, fraternité, and courage. These arches are actually brighter parts of the ring. Scientists believe that these arcs are locked into their shape by the effects of the moon, Galatea. Some of them are twisted, but we can't yet explain this phenomenon. The three main rings are Gal, located 42,000 kilometers, or 26,000 miles from Neptune's center, followed by Leverrier and Adams. Lassell is a weak extension of the Leverrier ring. The latter is bounded by Arago. Leverrier, Arago, and Adams are narrow, around 100 kilometers or 62 miles wide. Gal and Lassell, on the other hand, are very wide, between 2,000 and 5,000 kilometers, or 1,200 and 3,100 miles wide. These rings are thought to be young, formed after the solar system. Neptune has 16 confirmed satellites. As Neptune is the Roman god of the sea, its satellites are named after lesser marine gods. Triton, discovered in 1846, is a large satellite 2,700 kilometers in diameter. It is therefore larger than Pluto. It orbits some 355,000 kilometers, or 220,000 miles from the planet. Volcanic, it spews out plumes of ice. This activity regularly modifies its surface, making it the second youngest planet in the solar system. Strangely, it orbits the planet in the opposite direction to all the other satellites. This peculiar motion suggests that it is a former dwarf planet reclaimed by Neptune. It will eventually break up when it reaches the Roche limit in 3.6 billion years' time, forming rings similar to those of Saturn. Nereid, the most distant, was discovered in 1949. It has one of the most eccentric orbits in the solar system. Larissa was discovered in 1981. Photos transmitted by Voyager 2 led to the discovery of Naiad, Thalassa, Despina, Galatea, and Proteus in 1989. 5 new moons were discovered between 2002 and 2007. Finally, in 2013, Hippocampus was discovered by combining several Hubble images. It is the smallest moon known to date. Like Uranus and Jupiter, Neptune also has Trojan asteroids, sharing its orbit around the Sun. Many projects have been abandoned in recent years. One proposal is currently underway through the Discovery program. The Trident probe would make a flyby of Triton and Neptune in 2038. A single flyby is planned, during which the data acquired should make it possible to determine whether the underground ocean predicted by the models is indeed present, and therefore whether this moon is potentially habitable. In 2030, the alignment of Uranus and Neptune would favor a space mission to these planets. But 2030 in astronomy is tomorrow. Such an important mission requires a lot of time and money. The European Space Agency has already announced that it will not be ready before 2050. Only NASA has the time to work on such a project. Otherwise, we'll have to wait until 2040 for the next alignment. The study of these planets has another major interest: understanding exoplanets of similar size. Around 40% of known exoplanets are the size of an ice giant. In 2010, researchers proved that a Jupiter-sized gas giant had survived the death of its host star. In 2000, researchers discovered the planet Osiris, 150 light-years away, in the constellation Pegasus. Its official name is HD 209458b. This gaseous planet resembles Jupiter in composition, but orbits much closer to its star than Jupiter does to the Sun. It is therefore much hotter. It is so close to its star that all its gas could evaporate within a few million years. All that would remain would be its solid core. This phenomenon would give rise to new planets, Chthonian planets, the planetary remnants of former gas giants. As you can see, there are several scenarios for the future of our gas planets. Now we come to the final point of our journey. We're leaving our solar system. Planets outside our solar system are called exoplanets. Telescopes are placed in space to get closer to these celestial bodies and send us the most precise images possible. One of the aims of these space observatories is to identify exoplanets. The Kepler Space Telescope, sent out by NASA in 2009, has discovered over 2,000 exoplanets in 9 years. In 1994, Michel Mayer and his student detected oscillations in the spectrum of the star Peg 51. These oscillations corresponded to a planet with a mass half that of Jupiter and a period of 5 days. They waited a year to confirm that it was indeed a planet, taking the time to check everything out. They call it Peg 51b. Today we have 5,640 confirmed exoplanets. Most of them are very large and gaseous. But as they orbit very close to their star, their properties are very different from those of our gas planets. But how far will this journey take us? Peg 51b is not only a Jupiter-like giant planet, it also belongs to a category of planets with no equivalent in the solar system: hot Jupiters. The discovery of Peg 51b was followed by several other planets of the same type. Peg 51b orbits just 7.5 million kilometers, or 4.7 million miles from its Sun. Hot Jupiters, which have now been studied for 25 years, are defined by a mass and size close to those of Jupiter and a period of revolution of less than 10 days. Hot Jupiter, WASP 121b, has a rotation period of 1.9 days. Surface temperatures can reach 4,000 degrees Celsius or 7,200 degrees Fahrenheit. Because they're so close to their star, they have a very high temperature. It's 10 times hotter than Venus, the hottest planet in the solar system. Hot Jupiters rotate synchronously with their star, so they always have the same side, the other being in darkness, like the Moon around the Earth. Scientists estimate that over time, the gases enveloping these boiling planets will evaporate under the effect of solar winds. All that will remain is a rocky metallic core. Hot Jupiters could help us better understand our gas giants. Thanks to them, we could unravel the mystery of Jupiter's center and finally be sure that a hard core is located there. Because yes, there's always a doubt. There are currently around 400 hot Jupiters. Hot Jupiters are easy to detect thanks to the transit technique. This involves analyzing the dimming of a star as a planet passes between it and us. Some scientists believe that hot Jupiters formed elsewhere than in their current location, much further away from their star. they would have moved closer together as a result of a disruption in their orbit. We are just at the beginning of acquiring the data needed to characterize hot Jupiters. These observations will then be extended to smaller, more distant objects. But if only 400 are hot Jupiters, what are the other exoplanets? There are also warm and cold Jupiters. So what is a lukewarm Jupiter? A lukewarm Jupiter is a gas giant whose mass is comparable to or greater than that of Jupiter, but whose temperature is between 230 and 730 degrees Celsius, or 446 and 1,346 degrees Fahrenheit. Most orbits of lukewarm Jupiters are eccentric, whereas the orbits of our four giants are practically circular. As for the cold Jupiters, they have the same mass as Jupiter and relatively low temperatures. Our four gas giants are cold Jupiters. There seems to be no critical size or mass for these gas giants. Some are 10 times the size of Jupiter, while others are a fraction of the mass of Saturn. Very large ground-based telescopes such as the European ELT, or its American equivalent, the TMT, will enable us to detect even more planets in the coming years. As you can see, the further they are from their star, the lower their temperature. They make up the bulk of the exoplanet population. But the universe has even bigger surprises in store for us. Last year, American astronomers discovered, somewhat by chance, a planet that shouldn't exist. Why not? Because its formation seems quite simply impossible. Placed in orbit close to a red dwarf, less hot and dense luminous than the Sun, it should not have been able to form. The mass of a red dwarf is deemed too small to form a gas giant the size of Jupiter, with a mass 40% of its own. For a gas giant to form, there must be enough material in the disk to form the initial core. If the disk then evaporates before the massive core is formed, a gas giant cannot be created. But it does exist. This forbidden planet is an enigma. Its current name is TOI 5205. It's so big that it blocks 7% of its star's light. Jupiter orbiting the Sun can be compared to a pea orbiting a grapefruit. TOI 5205 revolving around its star can be compared to a pea revolving around a lemon. This has never been seen before. But there's more. There are gas giants called super-Jupiters. Their mass is greater than that of Jupiter. Let's take an example. The star HD 114082 is located 310 light-years from us in the constellation Centauri. Its radius and mass are around 1.5 times those of our Sun. A team of astronomers has discovered a planet around this star. It was spotted using 2 spectrographs in Chile, as well as observations from the TESS Space Telescope. Its diameter is equal to that of Jupiter, but its mass is 8 times greater. This super-Jupiter orbits its star in 110 days, half the distance separating the Earth from the Sun. We've simply named it HD 114082b. It raises many questions, not least about its formation mechanism. We've seen where research stands on the 4 gas giants, Jupiter, Saturn, Uranus, and Neptune. Today, research is concentrated mainly outside our solar system. Several observation campaigns are underway, and the arrival of a new generation of instruments is enabling many new discoveries. The Hubble Space Telescope, operational since 1990, has increased our knowledge of exoplanets, black holes, and the expansion of the universe. Its successor, the James Webb Telescope, launched in 2021, operates mainly in the infrared. The Ariel space mission, recently selected by ESA for launch in 2026, will focus exclusively on transit spectroscopy. The Gaia mission, launched in 2013, monitors and characterizes nearly 1 billion stars in the Milky Way. These observations will be complemented by those of the Plato mission, launched in 2028. They will be more precise than those of the Kepler mission. Ground-based instruments are not to be outdone. ALMA is currently the world's largest radio telescope. With its 66 antennae, it provides us with new insights into the formation of the universe. It has the capacity of a telescope 14 kilometers, or 9 miles in diameter. It can see 100 times better than any group of telescopes. The brand new VLT, Very Large Telescope, is the flagship of European astronomy. It consists of several telescopes that can be used separately or together. Their power and precision are such that you could distinguish the two headlights of a car on the moon. These two telescopes are located in Chile's Atacama Desert, the best place in the world to observe the sky. Here, you can take advantage of clear skies and the distance from city lights. Our extraordinary journey through the vast theater of space, discovering the gas giants of our solar system, is drawing to a close. We've plunged into the mysteries of Jupiter and Saturn, explored the icy depths of Uranus and Neptune, and contemplated the possibility of life forms that defy our terrestrial understanding. These distant worlds, with their tumultuous atmospheres and extreme weather phenomena, remind us just how vast the universe is, filled with unfathomable mysteries. With the help of the Hubble Space Telescope, which probed space in the second half of the 20th century, astronomers attempted a daunting challenge: to draw a map of the cosmos, locate our solar system and the Milky Way in the universe, and predict their direction. Although Albert Einstein presented his theory of general relativity in 1917, suggesting that the universe was static and bounded, he was forced to admit his error 10 years later. In 1929, the Hubble-Lemaître law, predicted 2 years earlier by Lemaître, demonstrated that our universe is in continuous expansion, and what's more, at an insane speed. Like all galaxies, our Milky Way is caught up in a cosmic flux, triggered by the Big Bang. Since then, the early universe has expanded in all directions and at an ever-increasing speed. As a result, the distance between all galactic structures is growing ever greater. Like splashes, we imagine that galaxies move at similar speeds on either side of their starting point. But this is not the case. The force of gravity drives many objects to gather into clusters and superclusters. It precipitates the local cluster, the group of galaxies to which we belong, at over 2 million kilometers per hour, or 1.2 million kilometers per hour, in the direction of the Virgo cluster through the immense Laniakea group. In the 1970s, observation of their motion revealed that the expansion of the universe was not uniform. A deviation, reflected in variations in the offsets between certain galaxies, between -700 kilometers per second and +700 kilometers per second, or -430 miles per second and plus 430 miles per second highlighted an anomaly. The local group, among others, is deviating from the general expansion of the universe at a speed of 366 kilometers per second, or 227 miles per second, in the direction of the Centaur. In the deep cosmos, somewhere in the fuzziest zone of space, masked by our galactic plane, an invisible magnet seems to be drawing us into its meanderings. But this massive gravitational irregularity doesn't just affect the Milky Way. It attracts thousands of other nearby galaxies. This anomaly has been dubbed the Great Attractor. Its location, determined in 1986, places it between 150 and 250 million light-years from the Milky Way, in the direction of the Southern Triangle and ruler constellations. With its colossal force, attributed to a mass estimated at several tens of millions of billions of solar masses, this anomaly appears to operate from the gravitational center of the Laniakea supercluster. Above all, it has the ability to attract galaxies within a radius of around 300 million light-years. Despite technical innovations in astronomical observation, this superstructure remains an enigma. For some, it could be a confluence of dark energy, attracting to itself any galaxy close enough. For others, the anomaly could be the result of overdensity, a zone of very dense mass generating an intense gravitational attraction. The beginnings of an explanation emerged in the early 1980s, thanks to an international collaborative study. The largest concentration of large-scale matter in the near universe was detected in this hidden region of the cosmos. Known as the Shapley supercluster, this structure, of 44 clusters totaling 8,000 galaxies, spans more than 120 million light-years and weighs approximately 10 million billion suns. But the discovery of this megastructure is not enough to explain the anomaly. Although it has a staggering mass, it is only half of that needed to draw us to it. What's more, it seems to be located behind the Great Attractor, which still remains a mystery. But it's not just cosmic objects that are subject to the sometimes puzzling temperament of the universe. In the early 70s, 2 space probes were launched, with the mission of making an initial reconnaissance of the planets of the outer solar system. In 1972, Pioneer 10 was the very first spacecraft to break free of the asteroid belt and fly past the planet Jupiter before reaching the liberation velocity required to leave the solar system, followed by Pioneer 11. The second probe took the opposite direction the following year, heading for Saturn after a close study of the Jupiter red spot. Unexpectedly, as the probes moved away from the Sun, an invisible force seemed to hold them back in their respective launches. The appropriate model, taking into account all the effects that could influence the speed of this type of craft in interstellar space, turned out to be wrong. As early as the 1980s, astrophysicists noticed that their speeds were steadily decreasing, despite their opposing trajectories. Although the probes had fulfilled their mission, their observation was continued over time using the Doppler effect. For a long time, this phenomenon was downplayed as inherent to the probes themselves. Fuel leaks could have affected the probe's orbits. Or has the impact of radiant heat from the plutonium used, or of light on the solar sails, been underestimated? For some scientists, Newton's theories and Einstein's relativity are being called into question. This suggests that gravity could imperceptibly gain strength over enormous distances. But if so, why don't the planets themselves seem to be affected? In any case, the behavior of the Pioneer 10 and 11 probes continues to intrigue scientists. Delayed by 500,000 kilometers, or 310,000 miles in recent years, these two spacecraft have helped detect this anomaly, which, if not elucidated, could well upset the foundations of current physics. But before we enter our hibernation chambers and drift off into a deep sleep, let's take a closer look at one of Saturn's moons. Behold Titan, the only known cosmic object to exhibit a stable liquid surface mass. This feature, though extraordinary, is not the only one this satellite possesses. Even more disconcerting, near its north pole, in Titan's second largest sea, called Ligeia Mare, a luminous object seems to be playing hide-and-seek. Sometimes visible, sometimes nowhere to be seen, unlike its direct vicinity, this zone was explored as early as 2004 by NASA's Cassini probe. But it was in July 2013 that it was first spotted in images from the same probe, before disappearing again a few days later. The area, estimated at around 260 square kilometers, or 160 square miles, finally reappeared in images dating from August 2014. To everyone's surprise, its appearance was different from that observed 2 years earlier. Is it an object floating on the surface of the sea, which for some unknown reason remains static? Or is it simply a change in the landscape, suggesting the presence of dynamic geological mechanisms in Titan's atmosphere? Researchers have put forward several hypotheses about the nature of this strange island. It could be caused by waves linked to an atmospheric phenomenon, or it could be composed of gas bubbles emanating from the depths of this liquid expanse. The appearance could also be explained by the formation of methane ice, or even an increased concentration of suspended particles, such as silt floating between two levels of water. But for some scientists, these extraordinary changes on the moon's surface are akin to the seasonal changes on Earth. Indeed, they have noticed that this mysterious island has always revealed itself at the beginning of summer in the northern hemisphere. It could, therefore, be linked to seasonal events, but over a longer period than our 4 seasons. As you can see, it's not only nature on Earth that has some surprises in store for us. This discovery, like a waking dream, brings us back to our collective phantasm, finding another habitable planet. Our sidereal journey now takes us to a strangely dark area of space. I invite you to step out of your chamber and let yourself be absorbed by this strange universe, virtually devoid of any visible matter. Faced with this enveloping, even deafening blackness, the surprise is total. Here you are in the middle of nothing, or almost nothing. But don't panic. Don't let this frightening environment overwhelm you. We're not sinking into an endless cosmic hole. Although space seems to be dotted all over with objects of varying luminosity, there are a few vast places where, strangely enough, emptiness dominates. We're currently right in the middle of one of them. It's the local hole, also known as the Keenan-Barger-Cowie Void, or KBC Void. This structure, or local subdensity, is no more and no less than a vast expanse, where matter has a density around 20% lower than the average of the observable universe. Studied in 2013 by 3 astronomers, the local hole closely resembles a sphere, around 2 billion light-years in diameter. And I'm going to surprise you. This cosmic void isn't as empty as it looks. I could even say that your cosmic address depends on it. In fact, it contains most of the Laniakea supercluster, including the local group, and consequently, the Milky Way. Our Sun is only a few hundred million light-years from the center of the local hole. Here's another piece of information that's sure to baffle you. Cosmic voids like this one exist in dozens of other, less exceptional dimensions. The only cosmic void larger than the local hole is nearly 3 billion light-years across. Thus, when observed on a very large scale, the universe resembles a cheese of holes, with zones rich in matter and others largely empty. Our galaxy and its wider neighborhood are therefore evolving in an immense empty bubble. According to the cosmological principle, the distribution of matter throughout the universe is fairly homogeneous, even over vast observed areas. While this can be confirmed on scales of around 250 million light-years, when we look at even larger regions, these cosmic holes appear. But what's even more interesting is that these voids could explain the discrepancy in Hubble constant measurements. Indeed, depending on the observational methods used, the expansion velocity of the universe presents contradictory values, known as the Hubble tension. The velocities of thousands of galaxies just located and counted were found to be 10% higher than those predicted by the lambda cold dark matter model. Makes you wonder whether the standard lambda cosmology model is really reliable, doesn't it? Could it be that unknown forces or manifestations are influencing our universe? This could explain why the model's predictions turned out to be wrong after these observations. The KBC vacuum is therefore a density anomaly, which, in addition to challenging our current understanding of the dynamics of our universe, could provide the beginnings of an explanation for some major inconsistencies. Scientists at the University of St. Andrews recently put forward a hypothesis. The velocity fluxes of galaxies, i.e., the speed at which they move as a group across the universe, would naturally be higher in and near this cosmic void, rather than in constant acceleration. They suggest that galaxies located within, or relatively close to this void, would exhibit higher velocities due to differences in matter density and consequently discordant gravitational forces. In short, local variations in the expansion rate of the universe would be related to Newton's laws of gravity, which are supposed to apply uniformly throughout the universe. Thus, according to their theory of modified Newtonian dynamics, MOND, regions similar to this void would experience a weaker gravitational force, resulting in greater velocity, If this explanation proves relevant, in addition to challenging the foundations of gravity theory, it could mark the beginning of a new age in cosmological research. Your hibernation chamber, programmed to bring you gently back to a state of wakefulness, has just opened. Your eyes are immediately drawn outwards by countless luminous galactic filaments. Here we are, close to the largest superstructure in the universe known to date. You're looking at the Great Wall of Hercules' crown borealis, also known as the Great Wall of Hercules' corona borealis. This gigantic group of galaxies lies around 10 million light-years from our Sun, in the constellation of Hercules and Corona Borealis, as its name suggests. Its discovery, which dates back only to November 2013, can be explained in part by its remoteness. Scientists spotted it by mapping gamma-ray bursts, the dazzling explosions of the most powerful stars in the cosmos, far away and massive. But they had to be patient. Indeed, these explosions, which release more energy in less than 1/10 of a second than our Sun will produce in its entire existence, are extremely rare. In an ordinary galaxy, explosions of this type occur only exceptionally, at the rate of one every few million years. The stars that cause these cataclysms are very massive, requiring large quantities of matter for their formation. If these explosions can be used to pinpoint a galaxy or a large body of matter, they need to be the subject of lengthy study, involving the recording of colossal quantities of data. This is what astronomers set out to do, mapping these luminous phenomena from 1997 to 2012. To do this, they used the Fermi and Swift robotic satellites. The latter were designed to detect gamma-ray bursts by measuring their redshifts. The study of the data collected paid off. The map drawn up over 15 years of observation revealed 14 gamma-ray bursts with redshifts. What's more, these similar explosions were very close together. For scientists, there can be no doubt. This far-flung region of space is home to a very large group of galaxies and large quantities of matter bound together by gravity. According to their estimates, this structure, home to billions of galaxies, seems to measure 10 by 7.2 billion light-years. However, while it covers just over 10% of the diameter of the observable universe, it is only 900 million light-years thick. Until now, the largest observable structure in the universe was represented by the group of large quasars, measuring 4 billion light-years. To give you a better idea of these unusual dimensions, remember, our galaxy, the Milky Way, measures just 100,000 light-years in diameter and is only 2.5 million light-years away from its nearest neighbor, the Andromeda Galaxy. But how does this discovery fit in with the list of space anomalies? To cut a long story short, the Great Wall of Hercules' Corona Borealis doesn't fit in with the principle of cosmology, Albert Einstein's famous theory mentioned earlier. According to this principle, the entire universe is isotropic. Cosmology therefore stipulates that the universe is the same in all directions, spatially homogeneous, and similar at every point on a scale of several hundred million light-years. Thus, scientists who assume that matter has been evenly distributed since the creation of the universe predicted that no structure could be larger than 1.2 billion light-years. However, the Great Wall of Hercules' corona borealis is 8 times larger than this supposed limit, calling this cosmological principle into question. What's more, this imposing structure contradicts theories on the evolution of our universe. This glittering wall you can admire is some 10 billion light-years away from our Earth. This means that terrestrial observers have seen this structure as it existed 10 billion years ago. The famous Big Bang at the origin of our universe occurred 13.8 billion years ago. This difference is far too short. How could such a gigantic structure have formed in just 3.8 billion years? The existence of such a structure remains a mystery to astrophysicists. With their current understanding, they are unable to explain how it could have formed in such a short space of time. The Great Wall of Hercules' corona borealis could well compromise the veracity of the Big Bang theory. As their discoveries continue, astrophysicists are constantly adding to their list of enigmas to be solved. One of them is to explain the presence of rings around objects that shouldn't have them. As a reminder, only Saturn, Jupiter, Uranus and Neptune, the giant planets, were equipped with these attributes in our solar system until this unexpected discovery. Introducing Chariklo, an asteroid discovered in 1997 that orbits more than 2 billion kilometers, or 1.2 billion miles beyond Saturn's orbit, deep in our solar system. While it is the largest member of the Centaur asteroid class, with a diameter of 302 kilometers, or 188 miles, it has been favored by many observers since 2013 for its astonishing peculiarity. This asteroid, around 50 times smaller than the Earth, has 2 rings. See how dense and narrow they are. Estimated at just 5 kilometers or 3 miles wide, they orbit at an estimated distance of 400 kilometers or 250 miles from the primary object. It is the smallest celestial body encircled by rings discovered to date. But it's not the only one. In 2017, a second such discovery was announced, this time concerning a small planet in the Kuiper Belt. Look at this piece of rock showing off its rugby ball appearance. It's Haumea, a dwarf planet averaging 6.5 billion kilometers, or 4 billion miles from our Sun. While trying to determine the size of this object, detected in 2004, astronomers discovered its particularly dense equatorial dust ring. No fewer than 12 telescopes pointed their lenses in Haumea's direction as it passed in front of a star, the ultimate condition for determining its dimensions. But to the great surprise of the researchers, a rapid extinction preceded the passage of this dwarf planet in front of the luminous star. They were able to establish that this dwarf planet, with a diameter approaching 2,000 kilometers, or 1,300 miles, is surrounded by a fairly narrow ring, around 70 kilometers, or 44 miles, but particularly dense, which orbits it at a distance of around 1,000 kilometers, or 620 miles. No explanation has yet been found for the origin of this ring. Is it an ephemeral phenomenon, or is it long-lasting? What is certain is that this anomaly could indicate that rings surrounding dwarf planets may not be as rare as scientists previously thought. In fact, an even more sensational discovery was made in the following years. This time, a ring was detected near an even more distant trans-Neptunian object. Meet Quaoar, a dwarf planet whose ring is not only unpredictable but also curiously located, hence its late discovery. In fact, Quaoar was discovered in 2002, while its ring was only recently detected and revealed to the public in February 2023. Quaoar was discovered by a team of American astronomers during Caltech's large-scale sky survey. As they surveyed the Kuiper belt for the brightest objects, their attention was caught by a dark object of apparent magnitude 18.6. It was moving slowly in relation to its background, a cloud of distant stars. Scientists call this phenomenon occultation. Its diameter, quickly estimated using data from the Hubble Space Telescope, is around 1,110 kilometers, or 690 miles, giving it the status of a dwarf planet. It is also one of the largest objects in the Kuiper belt. In addition to its size, this dwarf planet has a satellite. It's a moon, about 170 kilometers or 105 miles, called Weywot. But what's even more incredible is that this small planet, which orbits our Sun at a distance equivalent to 43 times that separating the Earth from the Sun, is surrounded by an extraordinarily distant ring. With a radius of 4,100 kilometers or 2,600 miles, it lies well beyond the Roche limit, defying previous models for the formation of such a structure. No other ring has ever been detected so far from its planet. This one is more than 7 times its radius, marking the boundary of the Roche limit. According to this model, a ring could not exist beyond 2 to 3 times the radius of the central body. This discovery is an anomaly for scientists, running counter to the above-mentioned model, whose origin lies with astronomer Eduard Roche. The rings are not supposed to exist in such a remote perimeter. The particles of matter present in this zone should have agglomerated with each other, since they are not subject to the tidal effects produced by the main body, which are greater than the gravitational cohesion forces taking place between them. And yet, despite being outside the Roche boundary, these numerous pieces of debris don't seem to be undergoing this long agglomeration process at all. So how does such a ring manage to endure over time? Here is one more mystery for astrophysicists. The icy temperature of the ring's debris could provide the beginnings of an explanation. Some scientists believe that the ice particles undergo so-called elastic collisions, preventing them from sticking together. So what you have before you is an exceptional, unusual, even inexplicable ring, at least for the time being. Admittedly, it doesn't have the splendor or grandeur of Saturn's rings. Nevertheless, its position in relation to Quaoar makes it unique, especially as it hides the secret of its very existence for the time being. But how about a little rest? After observing these anomalies, each more disconcerting than the last, a good night's sleep will enable us to tackle the next stage of our exploration with slightly clearer skies. The next time we wake up, a new surprise awaits you. Look at this exceptional star. This is Tabby's star, one of the most mysterious and exciting stars in the Milky Way, just 1,470 light-years from our Sun. Tabby's star, which cohabits in the constellation Cygnus alongside numerous other luminous objects, stands out from its companions in a singular way. Although first detected in 1890, Tabby's star has been the subject of particularly close study in recent years. The reason for this is its unusual light fluctuations. While the Kepler Space Telescope recorded variations in the brightness of over 100,000 stars in the Cygnus and Lyra constellations, data collected between 2009 and 2013 led astronomers to take a closer look at this star. For scientists searching for exoplanets, the brightness fluctuations recorded are unmistakable. There is probably a large mass or many small masses in close formation in its vicinity. This is why there is so much interest in this star, potentially accompanied by an exoplanet. Observations show that the star displays an atypical light curve for a number of reasons. It shows both periods of deep decline and long-term changes. On several occasions, its brightness has declined to as much as 22% of normal. What's more, a study of the archives revealed that this seems to have been happening repeatedly over a number of years. Now, if a planet the size of Jupiter were to occult this star, not only would it lose no more than 1% of its brightness, but more importantly, these changes in brightness would be cyclical. Except that, in this case, the fluctuations are totally random. Scientists then speculated that it could be an occultation linked to a random phenomenon occurring between Tabby's star and the observation zone. But this hypothesis doesn't hold water, especially as periods of significant brightening have also been recorded. I'm not going to hide the fact that the idea of an extraterrestrial megastructure has occurred to a few followers of this dogma. A Dyson sphere set up by an alien civilization would then be able to appropriate some of this light to meet its energy needs. But this idea was dismissed as preposterous by most. In fact, as you can see, there's no sign of any unknown technology being installed. But then what could be blocking the light from this star during the darkening phases we've noticed? The most simplistic hypothesis suggests that irregular dust clouds or orbiting debris could explain this phenomenon. However, the researchers noted that the infrared wavelengths of light pass through the gradation more easily than the ultraviolet bands. For them, this observation rules out the possibility of a solid object. Could it be the debris of an exoplanet? Or an exolune torn apart by the star? Or could it be several groups of comets sailing alongside it, like swarms of bees? Or are they inherent fluctuations of the star itself, like the famous Betelgeuse? But in that case, why these versatile variabilities? Could it be that the star is undergoing a natural process that means it has reached a critical stage of phase transition? Whatever the case, in order to unravel this mystery, scientists need to be sure of one thing. If it's an interference due to the superposition of an occulting material, they'll have to confirm its circumstellar nature and then its nature? If this is not the case, new alternative models for starlight could be developed. And what about you? What's your opinion on this anomaly? Just a stone's throw from this star with its strange behavior, we broach the subject of extraterrestrial entities. This must remind you of an unusual phenomenon you've probably heard of, still considered an anomaly for want of a plausible explanation. On October 19, 2017, a mysterious object was spotted as it passed through our solar system, baffling astrophysicists for many reasons, with some even considering the possibility of extraterrestrial technology coming to visit us. This fabulous object was detected by Hawaii's Pan-STARRS telescope and christened Oumuamua, scout or messenger in the Hawaiian language. Its hyperbolic trajectory and unusually high speed led to the conclusion that it came from another star system. Coming from who knows where, this bolide was the first interstellar object to visit us so closely, before continuing its long journey to an unknown destination. With its cigar-shaped ship-like appearance, it brought to mind certain cinematic images, often ominous. As you can imagine, this interastral intruder did not go unnoticed for a number of reasons. First of all, its dimensions. Measuring in length between 200 and 400 meters, or 600 and 1,300 feet, with a width 10 times less than its length. What's more, the object's brightness and variations in luminosity could lead observers to believe that it was a metallic object rotating on itself. Once again, science fiction films are full of spaceships based on similar movements. Its appearance wasn't the only thing that puzzled scientists. Its attitude proved just as disconcerting. While from a rational point of view, it resembled an asteroid or comet, it displayed neither the sparkling tail nor the halo usually attributed to the latter. Even more disconcerting was the way it crossed our solar system. When it was detected at a distance of around 30 million kilometers, or 19 million miles from the Earth, its speed was estimated at 50 kilometers per second, or 31 miles per second. Then, as it drew closer to our Sun, it accelerated progressively until it reached 87 kilometers per second, or 54 miles per second. But perhaps the strangest thing about it was its rocket-like behavior. Indeed, after orbiting the Sun, it experienced an extraordinary acceleration as it changed its trajectory. At that very moment, it was traveling at a speed of over 300,000 kilometers per hour, or 185,000 miles per hour, heading for the constellation of Pegasus, before finally exiting our solar system. Scientists theorize that such a brief visit by such a cosmic object could have been the result of a spacecraft. Could it have been a simple asteroid, an atypical comet, a hydrogen iceberg, or the debris of an exoplanet? Naturally, researchers tried to unravel this mystery by mining the data collected, specifically those concerning this fabulous acceleration coupled with an improbable change in its trajectory. Neither a gravitational kick from the Sun nor an outgassing phenomenon seem to explain this supernatural behavior, contrary to the laws of physics. What's more, no unusual radio emissions were detected during the same period. Since 2019, A study by the Astronomy Department of the University of Maryland has settled one point. The object did not originate from an alien entity, and its natural origins were justified. According to a study published in Nature magazine in March 2023, it is a water-rich object, similar to a comet that has undergone significant weathering. It reports that Oumuamua, like comets, is essentially composed of water and rock. The object would have been propelled far from its star's gravitational grip before drifting off into interstellar space. During its long cosmic wanderings, it would have been bombarded by cosmic rays, particularly energetic particles that can penetrate dozens of meters beneath the ice. According to one model, more than a quarter of the water molecules present on Oumuamua were transformed into molecular hydrogen, which was then trapped in countless small pockets of ice. When the object got close enough to our Sun, at a distance of tens of millions of kilometers or miles, the hydrogen ice would have undergone a sudden change of state, transforming into gas. By escaping on its own, the hydrogen gas would then have propelled Oumuamua, causing the abrupt change in direction observed. This hypothesis, which holds true for many scientists, helps explain why no halo or streak was detected by telescopes in 2017. The exact nature of Oumuamua cannot be certified to this day, leading, as you've seen, to major discrepancies in the sphere of astrophysicists. This object has definitely left our solar system, taking with it a mystery that will never be solved. However, future observations by the Vera Rubin telescope in Chile, due to begin in 2025, could well change all that. Designed to detect new comets, both inside and outside the solar system, it should be able to collect relevant data on them. If, like Oumuamua, the smallest comets show signs of releasing trapped hydrogen and do not display a characteristic tail, then the existence of this new type of comet could be confirmed. How about that? Our onboard computer reports that it has recorded a radio signal that seems to be repeating itself on a regular basis. Let's take a closer look. The transmission comes from the constellation of Sobieski's Shield, east of the tail of the serpent. The ground team confirms that they too have detected this unusual signal. They tell us they've observed the signal lasting from 30 seconds to 5 minutes, repeating itself strangely, slowly every 21 minutes. Our cross-reference data indicates that we are indeed interested in the same phenomenon. What could be behind such a radio source? Could it be an extraterrestrial radio signal? Of course it could. But let's not panic. This signal mustn't be perceived as a threat. Let me explain. This intriguing radio signal was first detected in 2022 by Australia's Murchison Wide Field Array Radio Telescope, before being observed and then confirmed by numerous other facilities worldwide. In a study published in July 2023 in the journal Nature, researchers from Australia's Curtin University report their findings. Although they are not yet in a position to catalog the object perfectly, they do offer some explanations. It turns out that this extraterrestrial signal is emitted by an astral object named GPM J1839-10. Yes, you heard me right. It's coming from a star, not from an entity potentially in search of traces of distant life. However, this stellar object, which behaves like a pulsar or magnetar and is located 15,000 light-years from Earth, has left scientists stunned. Radio signals from such stars, sweeping across our Earth on a regular basis, are nothing out of the ordinary, you may say. And yet, there's nothing coherent about this one. As you probably know, magnetars, or dying stars, produce energy at regular intervals. These neutron stars, with their extremely powerful magnetic fields, are particularly dense, rapidly rotating objects. The flashes they produce last only a few milliseconds, rarely more than a second or two, and are repeated at a steady rate of no more than a handful of minutes. In this particular case, let me remind you that the powerful radio beams detected last up to 5 minutes and are repeated only every 21 minutes, which is inexplicably slow for such an object. Such periodicity has never been observed before. Could it be that scientists have spotted an exotic object never before discovered? Subsequent study of the telescopic archives revealed another fact about these enigmatic radio wave emissions. The scientists, totally baffled, asserted that these have been recurring since at least 1988. This means that the star has been transmitting in this way for over 35 years. In January 2022, the discovery of a similar object, J1627-5235, was also announced. This transient object also emitted strong radio emissions lasting 60 seconds and recurring every 18 minutes. However, according to recent monitoring and archive data, its radioactivity was short-lived compared with that of its counterpart. It lasted just 3 months out of 8 years of observation. If it is indeed a magnetar, such a discovery calls into question current knowledge of this class of neutron stars. As they age, their magnetic fields gradually weaken, inevitably slowing down their rotational speed. Then, when they reach the death line, the threshold at which they can no longer produce high-energy emissions, they fall silent forever. In our case, however, this limit has been well exceeded. Nevertheless, this beam of radio waves continues to rotate, like a tireless cosmic beacon. Scientists believe that it could be an extraordinarily slow magnetar, or even a white dwarf radio pulsar, but one thing is certain. Even if one of these two hypotheses proves to be correct, both involve numerous parameters and uncertainties that remain to be elucidated. Let's add this new anomaly to the many other cosmic mysteries and continue our journey. Let's make sure everything's okay, shall we? What are you staring at? What are you saying? A curious circular mist? Yes, it is. Our radio wave measuring equipment is categorical. Straight ahead of us stands a strange ring of cosmic smoke. Its ghostly appearance partially obscures the stars in the background. If we were observing it through a telescope, I'd certainly advise you to clean your lens. A priori, this enormous structure, large enough to contain entire galaxies, is only detected in the radio range. None of our other measuring devices seem to perceive it. This reminds me of a recent discovery. I think we're looking at an odd radio circle, or ORC for the more erudite. The first such object was detected in 2019 by astronomer Anna Kapinska. When she presented this image to Ray Norris, a science professor at the University of Sydney in Australia, she named it WTF, for what the fuck, which shows just how disarming, even frightening, this discovery proved to be for her. Before publishing the result of this astounding discovery, the astronomers preferred to wait several months. In particular, they wanted to be sure that the signal detected was not an astronomical mirage that could be attributed to the measuring equipment. Further data collected by an Indian radio telescope confirmed this unusual discovery. No plausible explanation for this strange radio circle, which resembled a ball of smoke, could be found. For some, this puzzling phenomenon could be linked to a wormhole. For others, it could be the result of an explosion in a deep space galaxy, or a collision between a powerful neutron star and a black hole. Just a few days after this exceptional discovery, a second strange radio circle was detected, proving that this was not a unique case. To date, only 11 strange radio circles have been spotted, but researchers believe that thousands more could well be discovered in the not-too-distant future. However, observing them is proving very difficult. These structures, although colossal, with a diameter of several 100,000 light-years, 10 times wider than our own Milky Way, are billions of light-years away. What's more, as mentioned earlier, they emit light only at radio wavelengths. Since then, Ray Norris and his team have taken a very close look at the very first strange radio circle discovered. To do so, they used the Meerkat antenna array at the South African Radio Astronomy Observatory. With 64 domes, each measuring 13.5 meters, or 45 feet in diameter, this is the world's most sensitive and precise radio wave equipment. The anatomy of this foggy ball has been revealed to scientists, revealing itself to be far more complex than presumed. The spherical structure is made up of several intersecting arcs. Above all, at the very heart of this system, a tiny dot has been spotted. It is possible that this dot, which also appears in images taken at other wavelengths, is an immense elliptical galaxy. For the researchers, there's almost no doubt. These two elements, the strange radio circle and the galaxy, are linked, the latter probably being at the origin of this anomaly. But how? The origin of this huge ring of radio waves remains a mystery, and various hypotheses are being discussed. The first suggests that the galaxy in question experienced a period of intense star formation. Their successive cataclysmic births and deaths would have violently pushed back the surrounding gas and particles, triggering an expanding shock wave. The second theory suggests a collision between two supermassive black holes located in the interior of this galaxy. This strange radio circle would then be a shell formed by outgoing galactic winds. This scenario, if it exists, has never yet been observed, although it is one that greatly arouses the curiosity of astrophysicists. Finally, others believe that we are simply looking at the barrel of a powerful jet, emerging from the active nucleus of this same galaxy. As the exact origin of these strange radio circles remains unresolved, I suggest we divert our trajectory so as not to travel too close to this gigantic structure. After all, the consequences it could have on our interstellar journey are unknown. Now that we've reached cruising speed, I suggest you take in the scenery. Look out into the distance. The stars are covering the cosmos in all their glory. You have the privilege of admiring an area of space that is home to a huge cluster of galaxies. Meet the Giant Arch. With its crescent shape, this grouping extends over 3.3 billion light-years. Distant from our galaxy by 9.2 billion light-years, it is one of the largest structures ever observed. Made up of galactic clusters, galaxies, and abundant amounts of gas and dust, it stretches across nearly 1/15 of the observable universe. To give you an idea of its scale, the Giant Arc, if visible to the naked eye from Earth, would represent, despite its remoteness, almost 20 times the width of the full moon. If it was only discovered in 2021, it's because such a structure, according to established models of the cosmos, isn't supposed to exist. According to the Standard Model, the current theoretical limit predicts that the size of a structure should not exceed 1.2 billion light-years. And yet, the 45 to 50 galaxies in the Giant Arc are bound together by gravitational forces, as in any galaxy group. It was therefore detected by chance, while a scientist named Lopez was assembling maps of objects in the night sky using the light from 120,000 quasars. She then realized that the specific signature of certain halos from several dozen galaxies was similar. Mapped in 3 dimensions, the structure discovered turned out to have this atypical arc shape. To assess the probability of galaxies forming such a vast alignment in space, the scientists used 3 different statistical methods. All of them showed that the hypothesis put forward was not all that fanciful. The discovery of this gigantic galactic arc calls many things into question, but it's not the only one to baffle astrophysicists. The Great Sloan Wall and the giant GRB ring, with respective diameters estimated at 1.38 and 5.6 billion light-years, are 2 other unlikely groupings already observed. The Great Wall of Hercules Corona Borealis, visited a little earlier, remains the largest known structure in the universe, totaling 10 billion light-years, whose existence also continues to raise many questions. With our eyes immersed in this ultra-large structure, we've completely forgotten about our surroundings. Let's take a step back and look at the Giant Arc's surroundings. What do you notice? Isn't there another imposing structure looming in front of you? In this same region of the universe, close to the constellation Bouvier, another grouping of galaxies forms a gigantic ring of light. But unlike other circular structures, this one resembles a helix, taking the form of a complex spiral. While this unusual appearance is striking for any seasoned observer, its dimensions are once again beyond comprehension. This colossal structure, with a diameter of around 1.3 billion light-years, has only just been detected. The announcement of its fortuitous discovery was revealed, also by Alexia Lopez, at the 243 meeting of the American Astronomical Society, which has just taken place at the start of 2024. The Great Ring, as this new structure has been christened, is almost similar in size to the giant arch discovered 2 years earlier. If this structure could be opened up into a curved shape, its circumference would equal the length of the giant arch. To get a better idea of the ring's gigantic size, consider that if it were visible to the naked eye from Earth, it would cover the night sky like 15 full moons in a row. In addition to their extraordinary dimensions, i.e. in excess of 1.2 billion light-years, the theoretical size limit, these two giant structures also raise another question for cosmologists. Given that the giant arch and the Great Ring are located in the same region of the cosmos and at the same distance from Earth, is it possible that they are connected to each other? In short, that they are part of the same, even more extraordinary cosmological system? These latest discoveries add up to new evidence that compromises our current understanding of the universe. Once again, the cosmological principle that matter is homogeneously distributed throughout the universe may well be proven wrong. Shouldn't scientists start examining this possibility? Shouldn't they shatter what they once believed to be irrefutable, i.e. all manner of theories and rules governing the laws of the universe? Crazy as it may sound, many scientists say they're ready to consider it. But before they can do so, they'll need even more convincing arguments. For this, new research in the direction of as-yet unexplored objects or structures, which are consequently very difficult to detect, will have to provide new tangible proof. However, another argument is also being debated by astrophysicists. Some so-called impossible or early galaxies tend to confirm that the cosmological principle may well be obsolete. Thanks to new observations by the James Webb Space Telescope, scientists have discovered almost half a dozen galaxies that appeared just after the Big Bang, displaying unexpected characteristics. To everyone's surprise, these galaxies are so massive that they could call into question their very origin. Joel Leha, professor of astronomy at Penn State, announced that instead of tiny galaxies, they had detected disconcertingly massive ones. These turned out to be as mature as the Milky Way in a region of space then considered the dawn of the universe. The galaxies studied show a redshift, appearing to be approximately 13 billion light-years old. Admittedly, according to scientific consensus, our universe was born some 13.8 billion light-years ago. But that means they would have reached maturity in just a few 100 million years after the Big Bang. The idea is simply inconceivable according to the standard cosmological model. These luminous groupings of stars are so massive that they are impossible in 99% of models of the early universe. What's more, they are astonishingly small, adding to the mystery surrounding them. So how do we explain their existence? How can galaxies from the early universe be in such an advanced state of growth, corresponding to billions of years of cosmic evolution. For the researchers, there had to be a mistake. Although every effort was made to locate it, it could not be found. Could it be that galaxies were formed more than 26 billion years ago? That's what Rahendra Gupta, assistant professor of physics in the Faculty of Science at the University of Ottawa, suggests. For this scientist, our universe could actually be twice as old as current estimates. This would not only shed new light on those impossible early galaxies, but also provide an explanation to the existence of stars like Methuselah, the stellar Doan that seems to have been shining longer than our universe. Rahendra Gupta is the originator of a new way of thinking and explains how his model stretches galaxy formation times by billions of years. In this hybrid model, he combines the evolution of Paul Dirac's coupling constants with a controversial theory, Zwicky's tired light theory. According to this theory, the redshift of distant galaxies is due not to the expansion of the universe, but to a gradual loss of photon energy. The photons would be progressively stripped of energy as they traveled the very long cosmic distance to the observer. As for Paul Dirac's coupling constants, these are fundamental physical constants that govern the interactions between particles. These may have changed over time. To sum up, according to the synthesis proposed by Professor Rahendra Gupta, the redshift exhibited by these incredible galaxies could be attributed to two phenomena. One is the expansion of the universe, the other is the fatigue of observed light. For the scientist, our universe could therefore be exactly 26.7 billion years old. The distant universe fascinates astrophysics experts and enthusiasts alike, all the more so when our Earth is hit by one of the most energetic cosmic rays ever recorded. Named Amaterasu, this strange cosmic ray was detected on May 27, 2021 by the Array Telescope Network. With its unrivaled power, it surpassed the first phenomenon of its kind detected in 1991, named Oh My God, and which motivated the Telescope Array project. Over the past 3 decades, more than 30 ultra-high energy cosmic rays have been detected, but none of them reached the power displayed by Oh My God until this latest discovery. Nicknamed Amaterasu after the Japanese goddess of the sun, this cosmic ray, composed of accelerated particles, is baffling scientists for several reasons. The first, of course, is its extraordinary power. The kinetic energy of just one of these particles has been estimated at that of a tennis ball thrown at nearly 150 kilometers per hour, or 90 miles per hour. While this ray, invisible to the naked eye, has remained in the shadows for the average person, it did not fail to panic scientists measuring instruments when it was detected in the Utah desert. But even more disconcerting is the fact that nothing seems to be at the origin of such a phenomenon. Neither our galaxy nor neighboring galaxies. Indeed, after tracing its trajectory, the researchers were able to trace the source of this cosmic ray, or so they hoped. After all, it seems to come from a region of our universe that is virtually devoid of galaxies, and therefore relatively poor in matter. So how do we explain this flow of atomic nuclei and high-energy particles? What mechanism could have generated this extraordinary cosmic ray? Once again, to explain Amaterasu's origin, everyone has their own hypothesis. For some, it could have been particles emitted from our galactic surroundings, an event sufficiently discrete that no energy release or gamma-ray burst is detected by our instruments would then be the origin. This hypothesis calls into question the distant origin of the cosmic ray. A second theory suggests that the cosmic ray was deflected by an extragalactic magnetic field much more intense than originally thought. But the energy of the particles is so high that they should not have been affected by any magnetic field. Finally, the last hypothesis raises the possibility that this particle could confirm physics unknown to the standard model of particle physics. Critics also suggest that the Array telescope may have overestimated the energy of the cosmic ray. What's more, the exact nature of the particle detected is still an unknown factor that can change everything. Is it a proton? Or, for example, an iron atom? As in so many other cases, this discovery only adds more mystery to our universe, which is proving to be ever more complex. One of the most recent discoveries once again challenges our understanding of the cosmos. A team of astronomers from the U.S. Green Bank Observatory, led by Karen O'Neill, has just made an unprecedented announcement. A unique galaxy, christened J0613+52, has just been spotted. What's special about it? It has no visible stars. So the image we have of a galaxy as an immense grouping of luminous stars bathed in gas and dust is not always accurate? So say the astronomers who have just inadvertently pointed their telescope in its direction. The discovery, which was totally fortuitous, was due to an input error. As Karen O'Neill explains, an operator inadvertently set the Green Bank telescope to the wrong coordinates. Without this oversight, the object 270 million light-years from Earth would have remained in the shadows, and with good reason. It's a low-surface brightness galaxy, which is extremely faint, even for this type of galaxy. Aware of this parameterization error, the astronomers nevertheless decided to take a closer look at this structure, which at first glance seemed insignificant. Their curiosity paid off, enabling them to make a completely unexpected discovery. They soon discovered that unlike other galaxies with low surface luminosity, this one is particularly rich in gas. Its chemical signature suggests that it contains abundant quantities of primordial gas. Like spiral galaxies such as the Milky Way, it contains mainly hydrogen and helium. After measuring the wavelength shifts, an undeniable fact emerged. This galaxy seemed to rotate in the same way as an ordinary spiral galaxy. This gas cluster has all the characteristics of our own Milky Way. Its mass, composition, and motion all match, except for one thing. There are no stars in this vast gaseous region. Scientists have a new enigma to solve. Have they discovered one of the first primordial galaxies, which underwent no transformations during its 13.8 billion years of existence? Why didn't this galaxy, so massive and holding these elements formed shortly after the Big Bang, enrich itself, like its counterparts, through stellar explosions in the course of its evolution? For Karen O'Neill, the gas in this structure is too diffuse to allow it to collapse in on itself under the influence of gravity. What's more, this galaxy is totally isolated from any other structure in its immediate vicinity. It seems never to have been disturbed by any other galaxy. But these explanations are not enough to demystify this unique and fascinating recent find. Indeed, it's unlikely that over such a long evolutionary period, no gravitational force has ever disturbed its peaceful existence. And yet, this is what it seems to demonstrate. To better understand the nature and dynamics of the early universe, scientists will have to be patient. Future discoveries of cosmic bubbles that have not undergone any reshaping should help elucidate this anomaly, but they still need to be detected, as they are particularly discrete. Now it's time to return to our magnificent planet Earth. Let's plan our return. However, there's one last anomaly we'll need to overcome if we're to return in the best possible conditions. Our trajectory must absolutely avoid a vast zone located between South America and the southwest of the African continent. You may not know it, but this area is known as the South Atlantic Anomaly. It turns out that in this region covering the globe, a curious phenomenon has been intriguing scientists for several decades. The intensity of the Earth's magnetic field is unstable and much lower than in the rest of our planet. If we were to cross this zone, the consequences could be terrible for our spacecraft. Bombarded by high-energy particles emanating from our sun, all onboard technology could suffer interference, or even worse, a disastrous malfunction. But rest assured, this phenomenon, although unexplained, is not new, and we know perfectly well how to dodge it to bring this fantastic voyage to a close.